Hello and welcome once again to our second lesson of Industrial Electronics and 4. My name is C. Tobejane and this is Ehlanzeni College TVET Clinic. In today's program, we are going to be looking at a more complex circuit on superposition. If you can remember very well, on our previous lesson, we did a simpler circuit. Now in that circuit, we only had 3 resistors and then there were no much complications. We're able to use current divider rules to determine the current that particular load resistor will receive should a certain supply or a certain voltage source is supplying voltage to that particular current. And then at the end of the day, we were able once again to combine the two such that when they are combined, we know the current that is particularly supplied to that. So in today's session, we are going to be looking at a more complex circuit. If you can look at the circuit here, we have 5 resistors, and if you can check this, it's as if or rather we have 2 circuits connected to one main circuit. So we have 2 voltage sources. We have V1 here and we have V2 there. And now the question says calculate the current through the 9 ohm resistor. We are looking for the current through the 9 ohm resistor, provided when this voltage source produces current, it moves in that direction. This one moves in that particular direction. So the first thing that we must do as normal, we must short circuit a voltage. So if we short circuit V1, we short circuiting V1. When we short circuit V1, this would be our circuit. This would be our new circuit. This would be our new circuit, right? We put that resistor there. There's no longer V1 there. But what is it that we have now? We only have V2. We have V2 supplying in that nature. We have V2 supplying in that nature. So we have 3 ohms here. We have 8 volts there. We have 10 ohms here. We have our 9 ohms there. And we have our 7 ohms there. And lastly, we have our 4 ohms there. So this is the circuit. This is the circuit that we have. This is the circuit that we have. And then we need to be able to calculate the current that 9 ohms will get when this voltage is supplying. Our 8 volt resistor is the one supplying, right? So we need to calculate how much current will be received by 9 ohms. Now, you know how we go about doing this. So, first things first, we are going to calculate our total resistance. We are going to calculate our total resistance. We are going to start by calculating RP1. RP1 is a combination of 4 and 7. It's a combination of 4 and 7. So it's going to be 4 multiplied by 7 divided by 4 plus 7. This would give us what? This would give us 4 multiplied by 7 divided by 4 plus 7. This would give us 2.54. Let's write that in a proper way so that it can be visible. We need to make that visible. 4 ohms. And then there's RS1. There's RS1. RS1 will be a combination of our parallel and our 10 ohms. Our parallel and our 10 ohms. That will make it a series. So it's going to be 2.545 plus 10. This would give us 12.545 ohms. And then we now calculate the parallel combination now. We now calculate a parallel combination, because this whole system here becomes parallel to our 9. The whole combination here becomes parallel to our 9. So we're going to say RP2 is equal to 12.545 multiplied by 9 divided by 12.545 plus 9. This would be able to give us 12.545 multiplied by 9, 12.545 plus 9. This should be able to give us 5.240 ohms. This is our RP2. And then now, lastly, this one just goes straight and becomes combined to that. It will give us our RT. That will be 5.240 plus 3, and this would give us 8.24 ohms. This would give us 8.24 ohms. That is, why am I going step by step with this? When you get into the exam room, what happens is that the question paper may require you to show all intermediary steps. When you are required to show all intermediary steps, it means that you cannot just rush to the end. You must move step by step, such that the marker will be able to follow through the steps that you've calculated. Now we have something like this. The next step that we need to do is to calculate our total current. Calculate our total current. Total current is given by V over RT, and this is going to be 8 divided by 8.24. 8 divided by 8.24. This should give us 0.971. 0.971 amps. Now, after that, we need to find now the current that 9 will receive. So, what do we use there now? Remember, from our previous lesson, we said you use a current divider rule. You use a current divider rule. 98 ohms will be equal to opposite resistor divided by opposite resistor plus load resistor multiplied by IT. Multiplied by IT. Which one is our opposite resistor to 9? The opposite resistor to 9 is the combination of 4, 7, and 10. Right? 4, 7, and 10. Which value is that one? It is our RS1. This is the opposite resistor. Because this is how the circuit will be like. We're going to have our 3 here. We're going to have our voltage source there. We're going to have our 9 there. We're going to have our RS1. Can you see? If this is our R load, this is our immediate resistor, R immediate. So this will automatically be our opposite resistor. That will automatically be our opposite resistor. So the opposite resistor will be our RS1, which is 12.545 divided by 12.545 plus 9 multiplied by our total current when V2 is supplying. Our total current when V2 is supplying divided by 12.545 plus 9 multiplied by 0.971. This would give us 0.565 amperes. This would give us something like that. So now we've obtained our we've managed to obtain our current. when V2 is supplying, when the 8 ohm resistor is responsible in supplying. But now we need to calculate the resistor, or rather the current, when V1 will be supplying. When V1 will be supplying. So how do we go about that? We are going to say short circuit V2. When you short circuit V2, what is the next step that you do? You redraw the circuit with V2 omitted. You redraw the circuit with V2 omitted. When V2 is omitted, only V1 will be present in that particular circuit. Only V1 will be present in that particular circuit. You see? There. So we have our 4 ohms here. We have our 12 volts supplying there. Let me just draw a division line there. We have our 7 ohms. We have our 9 ohms. And then we have our 3 ohms. So same thing apply. The same thing apply. We need to calculate the total current here, right? So first things first, RP1. RP1 is going to be 3 multiplied by 9. 3 plus 9. This would give us 2.25 ohms. We calculate RS1, which is going to be 2.25 plus 7. This is going to give us 2.25 plus 7. This would give us 9.25 ohms. And then again we calculate the last, because we've calculated this and that. So now we move to that one, and that one will be our total resistance. Oh, there's a resistor here that we missed here. We missed a resistor there, and that is 10 ohms. So that resistor needs to be included. That resistor needs to be included. So we are not saying 7 here, but we are saying 10, and this will give us 12.25 ohms. That will give us 12.25 ohms. And then RP2 will be 12.25 plus 7. Can you see our mistake? 12.25 plus 7. This would be able to give us what? 12.25 multiplied by 7. 12.25 plus 7. That will give us 4.455 ohms. And then lastly, our total what? Our total resistance. It will be 4.455 plus our 4, and this would be 8.455 ohms. This is our total resistance. Can you see that? After calculating the total resistance here, we need now to calculate IT. IT will be equal to V over RT. Our V, which is 12, divided by 8.455 divided by 8.455. This is 1.419. 1.419 amps. Now, this is where the trick comes now. This is where the trick comes. Let us go back to our original circuit. I want to show you something here. Let us go back to our original circuit. Look at our original circuit here. When V2 was supplying, right? When V2 was the one responsible in supplying, it was easier to find the current here, because all of this became the opposite resistor. Can you see that? Can you see that? All of the resistors became the opposite became the opposite of who? Of 9. They automatically became the opposite of 9. But now, it is not like that. Now, 12 is supplying. Now 12 is supplying. When 12 is supplying, it means that the opposite resistor of 9, can only be what? Can only be 3. The opposite resistor of 9 can only be 3. But what happens to all of these resistors now? What happens to all of those resistors now? This is something that we must solve. Now, what is it that you must do? Here's what you need to do. This is the simplest way of doing it. Look at this. We are going to pretend like 7 was our load. We are going to pretend like 7 was our load, right? We pretend like 7 is our load, and then we calculate the current that flows through the 7. What does this mean? It means that we subject all these resistors to be an opposite resistor. We subject all these resistors to be an opposite resistor. So when we subject those ones, we are going to say I7 ohms is equal to R opposite plus R load multiplied by IT. What is our opposite now? Our opposite will be RS1. Our opposite will be RS1. In this case, this one is our RS1, 12.25 divided by 12.25 plus 7, because that is our imaginary load, multiplied by 1.419, multiplied by 1.419. So 12.25 divided by 12.25 plus 7 multiplied by that, and our answer will be 0.903 amps. Our answer will be 0.903 amps. Now, let's clear up some space there. So, let us go back to our original circuit. We have IT, we have the current that flows through the 7, and then we have the current that moves in that direction, right? So IT is 1.419 amperes, and we just calculated this current to be 0.903 amperes. We are looking for that current. Remember, 9 needs to get its current from him. 9 needs to get its current from him. So let us see. This current, we can name it X, right? This is Kirchhoff's law. So this current, we can name it X. What can we say? We can say X is equal to IT, or IX is equal to IT minus I7 ohms. This would be what? This would be 1.419 minus 0.903. This would give us what? 1.419 minus that, it will give us 0.516 amperes. So this is the current that flows in this direction. This is the current that flows in this direction. What does this mean now? This now will be the current that is shared amongst our load and the opposite one. Can you see that? And then again, we go to our equation. I9 ohms will be equal to the opposite over the opposite plus load multiplied by that particular current. In this case, our opposite will be 3. It will be 3 plus 9 multiplied by 0.516 multiplied by 0.516. So that is 0.516, and that is 0.516 0.129 amperes. But we are not done. We are not done. Remember, we still need to find the actual current that flows here. Now, the actual current that flows, erase this so that our circuit can be cleared. The actual current that flows here is a combination of a current from this side and a current from that side. Can you see that? Is a combination of a current from this side and a current from that side. The two currents come together and meet there. So it means that the total current of 9 will be equal to 0.129 plus, do you remember the one we obtained last time? The one we obtained last time, this one. This one, can you see on your screen? 0.565. 0.565. And now that will give us 0.694 amps. This is the current obtained by 9 ohms. It's very complex. Sometimes it may look difficult, but if you give it time, it is not difficult. There are many methods of calculating this. We are not subjected to one method. There are several methods you can apply to calculate the current flowing through the 9 ohm resistor. So this is just one method. First things first, you short circuit V1. When you short circuit V1, it means that V2 will be supplying, and when V2 is supplying, you calculate the total resistance showing all intermediary steps. You calculate the total resistance. After calculating the total resistance, you calculate the total current present in that circuit when V1 is supplying. And then after that, you use a current divider rule to calculate the current flowing through the 9 ohm resistor. And when you're done, you go back again, you short circuit V2, that means V1 will be supplying. You calculate your total resistance in that particular circuit, and when you're done calculating the total resistance in that particular circuit, you calculate the total current when V1 is supplying, and then you use a current divider rule to find the current that flows in that particular circuit. But then in this case it becomes a bit complex because you are further away from our load. It means that we had to pretend like our 7 is our load so that we get the current that flows through the 7, subtract it from the current that will be obtained this side, and then we find the current that flows through the 10 ohm resistor. And after doing that, we can just use that as our IT in our current divider rule to find the current that will be obtained by 9, provided 3 becomes your opposite resistor. When you're done with that simple thing, you add the two currents that you've obtained. It may look a bit complex, but with practice, when you continue practicing it, it will become very simple. Let me know, folks, if you need more examples of this, or if you need a simplest method or a detailed explanation step by step of this circuit, and then we can be able to meet here again and do that particular circuit. But for superposition, we're done. On our next session, we'll be doing more practically or more particularly on the same circuit but using Thevenin's method. In this case, that is another method that you'd find in the exam room. So I hope this session today was very helpful. And that's it for me. My name is Theorem. This is Ehlanzeni TVET Clinic, and I hope you check us out on our social media platform. Till we meet.